Okay, we're live. Cool. You know this. You know the procedure. I will tweet the link to the stream, and we can get started. I already pre-composed it, so we're good. There we go. Cool, and I can see it's live on YouTube as well, so we're good. Welcome. I would like to start quickly with mentioning that what I've been actually talking about for quite some time now, which is the footprints or Git submodule for my footprints and my symbols and 3D models, I guess, as well. So what I did is I created, that's interesting, the URL is called Stargazers. I never noticed that. You can see it there. So I created these two Git repos here on GitHub. They're under MIT license, so should be good for most people, and I haven't added anything to them yet. So actually what I could do right now is just git clone them quickly, so we can actually have a first project that uses these. So that should be fast. Hi Kilobyte. Right, so then I can move the old I already created. There we go. Right, now it's gonna be, oh yeah, I should have added that as a, I'll fix that later. Because I should have created a repo here and then added as submodules. Never mind. Anyway, I have the folders now, so I can commit like that and set up this properly later. So this is where we left off last time. not a lot here, but now I have checked some chips, checked some parts, and I know a bit more about which parts I want to use. And I have them right here, so I can close this now. So let's actually go back here for a second. So like I mentioned on the previous stream, I will need 2 voltages here, which I can get from the 3 volts on the PMOD, and then, well, all of them, right? But these two, no problem, and then the plus and minus 5 volt. So I need an inverter. So I found this quite nice chip over here. I think it's like a pretty standard, it's like a jelly bean part, but it's it's charge pump that puts out positive and negative voltage of like the same level. So if I what is it called? Not calibrate, but yeah, I set the feedback for 5 volt, then I will get plus and minus 5 volt, and then those 2 voltages are done. And then for backlight, I checked the data sheet for the display. It says it should not exceed 25 milliamps. So I found this nice, also from Texas Instruments for some reason. This nice LED driver here, fun light driver. Yeah, it can run up to 8. We have 6, so we're good. And then it has I2C for some additional stuff. So should be good enough, I think. Though it doesn't have the PWM output, so that one I could probably set up to directly like on the PMOD. But then we are still a bit, the problem is like it will not be enough pins on the PMOD connector on a single one, so I might need a double. And there are some LED drivers that actually have the ALS support. The what is it called? That's something totally else. I can actually close these. This is the one. So what was this called? The CBABC. So there are actually LED drivers that have support for that. So maybe not this one, but we can at least start today with this one. And I'm not sure if it is in KiCad, so let's have a look quickly at that. It is. So that was easy. Although I'm not sure if this if the pin locations here are quite nice, because like here they have this really nice way they made the symbol out plus minus minus out. Okay, and then there's ground. Oh, maybe that's actually fine, and we can fit some. I mean, worst case, I just clone this and adjust it slightly, so that shouldn't be a problem. Right, so VN, we have 0.7, so we can provide it with the 3 volts. Like this. No problem there. And then we have the grounds. And there we go, no problem there either. Then here it's just a capacitor. This is what I don't quite like about the symbol already. Like symbols to have one wire and not connect directly, because it just looks kind of bad. So I think I will actually now. So what I will do is I will clone this into my own library and then modify it. Wanted to copy this name, but it doesn't look like I actually can do that. Okay, then we need a new library, and that will actually be in this new Git repo now, so that's cool. Which capacitor? Correct. So there we go. I believe now we're in. It doesn't actually say which one I'm editing, but saves it. So yeah, it says here, so that's fine. So we can make a few modifications. Just like that, at least for now. And then this one, we need to add the new one. Yeah, it's quite convenient that KiCad actually allows having the same name for well, off by one over here. And that was in the actual official library. Library. It's not that nice that KiCad actually allows having 2 parts with the exact same name in 2 different libraries. That's the problem there. Now we can add that capacitor. And it should probably have a value. 1 UF over here. Yeah, typical high current or 1 UF 10 volt. Cool. 1 UF it is. 10 volts. I kind of miss, I don't know, because you could have a new field just for the voltage, but that's kind of pointless to have it that way. But this doesn't look so nice either. So enable plus, enable minus, and it will be enabled by the, or on, always on. I can pull them. I can, if they tell me which way, I would assume it's active high because they didn't have those. Active high, all right. I actually move some stuff around here. Because we go. There we need some decoupling over here. Just like that. Let's double check on that. I mean, that's the standard decoupling value, but maybe they recommend something better or worse. So there we go. Cool, and then the power good, which I think that's an output, which connect to ground if not used. And do I want it on a test pad or not, or a test point? Because if I connect it to ground, then that's it. It won't. I can't test it. Like in the application here, they have a pull-up, so you can still probe on it. It just has a defined default state. And actually, this fish 12. Go back here, power. Okay, so it defaults to power not good, or we default, and then pulls it down. I think I will actually. There we go. Cool. Yeah, let's add a test point just for fun. I think that board won't be that complicated, so maybe it will. Let's see. See, that's another thing I don't quite get. Like I set it to right, but now it's on the left, and I can like try to rotate it, but it's not rotating it 360. It's kind of rotating it 90 and back. That's just the quirks of KiCad, and I'm guessing it's because this symbol is actually rotated, like it's immersed, but that doesn't quite explain it. So yeah, I get it, but I don't like it. So there's that. Okay, that covers this. And then on the out, I'm still slightly right. I haven't talked about this, or maybe no. So let's see. Did I close it? No. Exactly. So here you can see on the positive and negative, it mentions plus 4.4 and minus 4.4. But in the pin names, you can find the pin out right here. It's actually called 5 volts. So twice, like in the description as well. So will it actually be okay to connect 5 volt to it, or will that be too much, like too high voltage? I don't know. And I'm hoping this won't break it. I think what I could try to do is, since you determine the voltage with the resistors, I could solder the resistors for 4.4 first. And if it doesn't work, and I assume like there's no any other reason, then I change them to be 5 volt and then try again and see if that fixes it. Because that's a safe safe bet, or like safe way to do it. So it was on page 12. Right, so there we have another I'm not sure this has to be, oh, this one has to be 10 volt, maybe, yeah. So example value 4 point. Yeah, this one is 2.2, the decoupling. Maybe it's not a decoupling then. In typical applications, recommends 4.7 low ESR ceramic char pump output capacitors. Cool. Then we do that. And there you go. Done and done. This will be too close to each other to fit. Yep. Ready. But let's draw them first. Although, was it said they recommend 4.7 or what was it, 1 UF in high voltage situations? But what is a high voltage situation here? Like this is max 5 volts, this is 5.5. So I'm not sure the heck do they actually mean. Let me just check one more thing. Right, 150 here, and it says in can up to 250, so we're good. Yep. So that part we're good. And okay, so we can draw this nice and quick. And it's just two caps, and our resistors. All right, and then these here. I mean, I can already see this. Maybe this. Right, and this goes to ground, and then we have a nice. Okay, let me just check it now so I don't have to go and correct it later. I think it said it was the same value for all three of those. No, it's actually 2. Right, it was 2.2. 2.2 it is. Cool. And then the input over larger. Was that C1 that I was also wondering about? Oh, it was the CVN. Oh, it's also 2.2. Okay. Let's see why not. I will move this way away. And I think we will modify here. Or let me copy this one. So then like this. Yep. Not connected like this. Yeah, right. This shouldn't be 10K. It should be like. Yeah, I know that I'm putting that in the value. That's not correct. It will be easier to read up that later. So there we go. And not to screw this up now. Cool. Then this one. That's actually ground, so nothing connects over here. Yeah, that's correct. A lot of space over here. This goes. Oh, why am I dragging this? Okay, that's too far. There we go. And there we go. Boom and done. So this one, 1, 2, 1, 2. I guess that's the same position. Yep. Move that one. There we go. There we go, indeed. Right, what I could do over here, or maybe not really. I move this one there. No, that I can't really short it. Yeah, this is fine. Yep. Right, and then there's nothing here. Perfect. So now we need to determine these. I should put that as like a text note here. I hope I won't be doing math on the stream. Because that might go badly. Or maybe not actually. That's fine. No less than 50K. Yep. Okay, that's logical. Be positive out and be negative is just exact. Oh, okay, the reference is slightly different, so the values will not be the same then. All right. Was that actually aligned? Again, this should be monospace. There we go. This is not monospace either, really. So let me just check one thing. Yes. Okay, so I wonder, do they have? Do they have more examples? Was this nice table over here, right? Pull up. Because I'm kind of wondering also if these, right, no less than 50. So that should be fine. Yeah, skip that because I will just psych myself out. Right, so I see this one is thinner than this because this is based on, yeah, there we go. Well, that means I think I've been doing my footprints actually, or my symbols wrong, because they should be, they should have a thicker border. But okay, now for just consistency, let's keep it at, let's keep at it. Oh, I actually put this here. Boom. Right, 300 milliamp max, but that's like momentary, so that should be fine, possibly. Yeah. Right, I think I had another. This one that I also had a look about. Had a look at it. Because this one had PVM. But that's the PVM in, isn't it? That's really yeah, maybe that's good. There was one really nice. The problem is the footprint was so tiny that I would not be able to make it on a was it this one possibly. I would not be able to make on a 2-layer board. Yeah, that was one of them. It was like 2755 and 56, I think. Was it? No, that's an inverter. So yeah, I'm not sure which one to go with, and if it matters really or. All right. So the LCD and PVM need to be also 285 volts. I might need a level translator, level shifter. That's annoying. LED driver. That's not it. Maybe I don't call that because call it like ALS or something. There you go. That's the one we just had a look at, I believe. Dynamic backlight control. But I'm wondering because if both the display and the driver need VM input, which we do, right? Wasn't there one? Oh, that's an output. Oh, right. Okay. Confused myself. So, right. So this drives the actual LED driver, and that controls the backlight. Yeah, that makes sense because I should have figured this out. Because I mean, it's the display knows what pixels are being shown and so on. So based on that, it can manipulate the PVM. So that's actually where is that one? Not this. This one. That could. Oh, that one does have PVM. So this is actually not a good candidate because I don't need the I2C. It's just a self-contained. Like the display will drive the backlight, so I don't need this, and that actually would solve my problem for the PMOD connector as well. LED driver. That misunderstood that slightly. This one, I guess, could work actually, and this one is a livable footprint. ADIM, one wire pulse. What do you actually clock in over here? Interesting. The LED current in all 6 channels equals to the programmed set via ADIM when PVM is low. Exactly. So it will. I mean, it's PVM. Actually, yeah, okay. From low to high, and I wonder, does that mean actually that if I connect this directly to, well, 1.3, that's really crappy because I don't have anything to, like I don't have that voltage anywhere really. Could it just be left hanging? Right, and then yeah, I get it. You clock it, toggle it to toggle the maximum current, and then it will go again. So it's just goes around. Yeah, okay, but then this is, I can just have it and see, since the full scale of 25. Yeah, I think this is fine. This is good. I think this will work. And I don't think there's a symbol for it. Interesting. Okay, then we actually do this. 47 nano, 0.4 to 5, so 3.3 works. Although there was a mention of 1.8 at one point somewhere. It's really strange that the explanation for the pins is actually like at page 9. Right, yeah, okay, that won't be a problem, presumably. Then I'm curious what voltage is the PVM at, or... Oh no, that's right, because this is an input, so it goes, yep. But then might mean if it expects 3 volt and it goes maximum to 285, then they will never go full brightness. But that's probably alright for like test board. Yeah, okay. So let's go for that. One thing to check, P7. I'm just curious which driver LED. That sounds, yeah, that's right. So this, it should be in driver LED extra. That's wanted to know. Really low on viewers today. Just the one viewer. Who is the one viewer? Is it still Kilobyte? I'm curious. Okay, so it's cool. So it doesn't need any control. It will just work on its own, presumably. I'm hoping. I don't need to write any like kernel driver for it or something. It should just work. Famous last words. So many of those. Okay. P1 plus, and that's, I mean, it's not really an input. It says positive, but then it needs ceramic capacitors, so those are not polarized, but no one cares. And also I did this wrong yet again. Will I ever learn? P2 minus, no, plus, doesn't quite matter. Let's keep it consistent. And we have the ground. Oh, this would be nice actually. For the first time in forever, I can use this. And there's a little frozen reference for you. Dim 12, and that's input. And these are actually all outputs. That's input. And then the capacitor for the PVM. Let's go to power output, but later that might change if KiCad gets cranky. And then the input and one more ground, 17. Ground. Brain fart. And I named it wrong. Not every time, but often. I don't know. And back to the first page. This seems quite right. Won't be quite. I think we can have these on this side. We can have V in, obviously, and then ground on the bottom. Something like this. Might have to adjust it. So 1, 2, 3. There we go. Would have been even thinner, but this is fine. And then we have the name and reference. Here we go, and just some fluff over here. Actually, I can try and see if the footprint is there. That would make it slightly easier. PQFN 16, sure. Show me a drawing. There it is. So 3x3 QFN. That's pretty small. What is the pitch over here? 0.5. That's standard. Maybe it's not that small. QFN. So it's been, yeah, we'll need to create footprint for that. How do we have the generate? Oh no, the TFN. I silly me. Yeah, there's so many, man. There you go. One of these, fine. So 3 by 3, yes, and 0.5 correct. And then the EP is 1.6 by 1.6. So it's more like this one. And 5 by 3, 1.7 by 1.7. That checks out. So that's all right. So I think this will do it nicely. Cool. And there you go. P649. 649. And we wait. And there it is. I have to fit caps here, so that will be way longer. So let's see how that goes. Maybe one goes on this side. And 0.3 was correct, I believe. Let's double check. I like this data sheet, it's so short. I mean, that's how you want them, right? Yep, 2.425, perfect. And then some one microfarad coupling. There you go. Right, so I should read up if this should be NC or pulled some way, like high, I guess. VM. I guess. That's it. It goes there, comes out, comes out, comes in. And then because I could have just copied from this schematic, it's way faster that way. Right? So what voltage flag can we put over here? No. The standard thing you do in this would usually put the voltage, but not on the. Not VBAT. I don't know how to figure it out. I just put VLED. Then we have the 6 LEDs. Correct. Yes. Let's put it here. So what should these caps B. It says 1 micro over here. I don't use 2V out. Oh, that's quite interesting. I mean, don't you kind of sort it? I mean, short LED of the LED. Okay, that explains. Reading is cool. Okay, so it doesn't actually mention, it just says use one sure thing. So, can I organize this any better? Doesn't look like it. Yep. And there we go. Round. That one should follow so it doesn't look, so it's not so long. I think this part it would be like way over here. So let's not do that. Yeah, I mean, to give it some brief, space. I think that's quite alright. And then third, second. I'm just realizing. I mean, that's the cathode going here. Like that's the ground and that's the out. But here we have the anode, so that's not correct, is it? Right, or am I wrong? I know there's one viewer, so probably no one will comment, but I need to double check this at some point. I check this one. Oh no, this is actually. I mean, I'm not. Yeah, the cathode. I have to check. Cathode is where the negative polarity goes, which means these are all cathodes over here, and that's the anode. But in the display, these are the anodes right here. So these should all be ground. And then the voltage should actually be applied here. I don't think I'm crazy. Just taking some reference off screen, no big deal. So the cathodes is 27, 25. Cathodes are ground. Yeah, so I can't use that one actually. But then that's some special kind of driver actually. Yeah, of course they don't have it because this is self-explanatory. So. Go here. Now I'm gonna be Googling on stream, so that's so interesting. What do we have here? Wow, that just leaves two, and one of them is the one I already used. Step up, sure. Yes, I wonder if I have to actually look for a common cathode. What about? I'm also Googling a bit on my phone. Data sheet. That could be manageable. Exactly, so that's almost there. That is silly that I did not realize this, but it's good I caught it. Definitely. So can I actually specify? Whoa, no, I thought that was 92 filters. Yeah, I can't search for that really. Really. I mean, it's important, isn't it? I'm trying to figure out how to specify that it's common cathode, but then it doesn't really say anywhere here. So how am I supposed to know that? The LED, so that's not enough. And it also doesn't have PVM. Oh. But where does it go? I said, is that PVM? That doesn't sound like PVM. Yes, have a look at the data sheet, why not? Right, so the enable pin is the PVM tool, but that still doesn't explain many things really. Like I need at least 6 channels to show me those parts. And then, oops. $25. Right, so we have all of these over here. And then package, I have to not the DSBG, I believe. Although the 16 maybe. How does this look? I don't think I can, because that's like 0.4 pitch. I cannot have that. I was hoping I would get more from TI. 8 channel, okay. Hmm. Yeah, I think I have to do this off stream because there's no point. So it's only been an hour, but I also started late, so maybe that's good enough. Or you know what? Let's look for some LDOs. Hmm. The MCP, maybe if it's the MCP in a bigger package, then it can provide more current. Because I can't use the smallest one, because I mean this is still max current, but I would like to exactly. So the 1 amp version. Oh, let's see anyway, because I think Mouser might not have them. The values just filled in, or maybe not. So even this slightly larger package, or yeah. Go and in stock and 1 output. Should filter a few, as you can see here. Okay, so the 1 VDD 500 max. So if we did something, do not have the big ones either, or all like just to have this kind of slice of current over there. Let's have some common parts maybe. 3223 3. Standard big one, quite big. What about in SOT 23, 25? Yeah, that works. Either of those. Nice. Do I know those? But that's like twice the price, even though the price is really cheap anyway, so it's not such a huge difference. Let's see. Yeah, this could work. So T25. To make sure with the current. Okay, so they're all 600 milliamps. Cool, that can work. Do they also come in? No, not in 285. Okay, but that I think that would work. Could actually add this quickly just to nice. 23.5, which isn't that 20? Let's. That's my. No. Oops. Yep. That's also wrong. What am I doing? 3D model. There's the button I wanted. Yeah, I mean that's the. That can be only that one. SOT 25. Yes, some people can 23-5. We can compare the pinout. Yes, to be sure. 1, 2, 3, 4, 5. Just start with that. 1, 2, 3, 4, 5. And then right. V in is 1, V out is 5, ground is 2, enable is 3, 4 is in C. Okay, so that's that one. You can copy the whole. Or is the K actually the code of the package? Because then I don't need the full name. It should be in the data sheet. So right, there we go. Yeah, so K means the package. Cool. So that's actually enough to know which one it is. So what we do is this nice here. This is annoying. Why do they make these symbols like this? Who approves this? That works. So this one 1.8, then 3.3 in. I think. I don't know what was the. I don't think the drop is gonna be so huge. So 3.3 should do it. Drop out 250. Cool. So that's no problem. And then what do they recommend for 1 and 1? Oh, like this is a nice drawing. Like definitely tells you active high, cool, perfect. Actually. Sorry, I actually had one here. There we go. Wait just a second again. Yep. Sorry, the message again. That works. Cool. So there's our 1.8. And then for the 285. I think I can change the value. Exact 700 max. Although again, that's peak. Okay. output voltage 285 there. Well, all right, because I limited on the package. There we go. So I guess for 285 you need a bigger package, which is might be fine. Yep, any of these will do. LT3, interesting. Yeah, what is it? Right, isn't that a 223 or something like that? Whoa, why are these so whoa? Because it's such a specific voltage. That's pretty bad. I wonder if we could do it with 2 volt, 2.8 volt actually. Because hmm. 0.85 times 0.3. Yeah, actually. That's like 2% of 1 point something. So 2.8 could work, I guess. Although that's for something else, but let's see. Yeah, let's look at the prices first and then where's the voltage I removed? No? Did, but I don't think it noticed or something like that. 2.8 it is. Right, so these super specific here, we could also do okay. There was another because it's 700 in rush current, but 50 while displaying an image. So to be honest, it wouldn't have to be so high. 'What's the range of voltage here? Not too far. $2.8, definitely cheaper. And pull 1 amp. I guess that could work. What is the DDB VR DB V DB? They're all like that because they all have the same pinout and the same footprint, which is once I think I can I can use one. Again, verify 1, 5, 2, and 3 for standard stuff. Not to scale. Cool. I can use any of those. There we go. What recommended values do we have here? Yep. Checks out. And I forget to change the grid. Yep. Yep. Yeah, okay. So we have the LD over here, then we have the actual display. And there's the inverter for the 5 volt. Let's actually leave it. This is a question mark, or actually I know fairly confident that's wrong. So otherwise, right. 1, 2, 3, 4, 5, 6, and then 8 here. So we do have actually 2 extra. If I wanted the reset, which I might actually want to pull down on, pull up on, maybe. But I think we'll conclude here. Need to figure out the LED driver. No point in going further without knowing that. But once that is done, we can actually be done with the schematic. What we could do is annotate it for sure, and actually do this because this assignment takes forever to load and it halts the stream. And I think again, yeah, like this actually works wide or right. We do 0603 some work. There SMD 0603. Yep. Oh, C5, I missed. Which one is that? Oh yeah, that was the. All right. Because I stopped. And the connector, which not sure. Seems like I haven't added it yet. But we can add the resistors. I mean, this has to be done at one point, so why not right now? That's a test point, so that needs a footprint as well. And KiCad these days has pretty nice test points. I'd rather have a circle. There we go. Right, all right. Yes, for that one I need to create a footprint, so let's not do that just yet. Okay. Cool. I think we'll finish here for today. So thanks for watching. Sorry for all the confusion. But maybe, yeah, maybe we learned something today to double check, triple check stuff. So, cool. See you next time. And thanks for hanging out with me.